Hello, my name is Florent and today I will present to you the LM10692. The LM10692 is a power management IC specifically designed for solid-state drive application. The LM10692 features 6 regulated channels, one of which can work as a load switch. The LM10692 integrates the power MOSFETs, the feedback, the compensation and control, and the sequencing of all the channels. This results in a very compact form factor and also helps in the design of the application. The LM10692 has been approved for and is integrated in the reference design of the SF3700 SSD controller, which is here. You can see the solid-state drive of this reference design, and you can see here the LM10692 and the power solution, which is about 12 by 8 millimeter. The LM10692 has 2 independent enable lines, one for the low power rails, the always on rail, and one for the core power and the flash drive, the CPE rails. The LM10692 has integrated active discharge circuitry on all the rails so that when the rails are shut down, the output voltage can be quickly brought to a low level to reset the solid-state drive. The LM10692 has a light load operating feature for the idle mode to reduce the operating current, and also has an I2C compatible bus to access extended functions such as individual enable of the rails, individual power good monitoring, and dynamic voltage adjustment, among other features. Here is the typical application for the LM10692 that is powering the solid-state drive controller and the flash drive. You can see here the 6 buck channels. Buck 2, 3, and 5 provide the low power rails, and buck 4, 6, and 1 provide the core power and the flash drive rails. And buck 1 is operated as a load switch and is supplying 3.3 volts to the flash ICs. The solid-state drive controller is interfacing with the LM10692 through the enable and the power good lines. Now here is the LM10692 standard evaluation module, which is connected to 2 oscilloscopes. One oscilloscope is monitoring the always-on rail, and the other scope is monitoring the CPE rails. So as I turn on the power to this device, you can see the always-on rail coming up in sequence, buck 5, 3, and 2, 500 microsecond apart. And this sequence is internally programmed. There's no external component required. And this is the proper sequence to power up the solid-state drive controller. After the always-on rails have powered up, 500 microseconds after, the core power rails come up, buck 6, buck 1 providing the flash, and buck 4, again in sequence and in a proper sequence to bring up the solid-state drive. If I disable, let me trigger on channel 1 here. If I disable the, if I bring the enable line low, you can see the CPE rail coming down at the same time, shutting down at the same time, and the active discharge circuitry turning on, which quickly discharges each of the rail to below 100 millivolts, which is necessary for the solid-state drive to properly reset. And so within a few milliseconds, those rails are below the 100 millivolt threshold, and this allows the solid-state drive to quickly turn back the CPE rails if necessary. When I re-enable the lines, re-enable the rails through the enable CPE line, you can see again buck 6, buck 1, and 4 starting up in the proper sequence needed to bring up the solid-state drive again. Now, I want to show you the low operating current of this device in idle mode. So for this, I will be using the mini evaluation module, which is here, which has none of the LED voltage sensing bridges on the evaluation module that are taking additional current. So we can see the current consumption of this solution. So you can see here the enable CPE line has been pulled low and only the always on rail are running. And you can see in this power analyzer here, the current consumption of this device is about 250 microamps. Finally, I want to touch on the heat dissipation. Since this LM10692 integrates 6 channels in a small LLP package, there is a concern of heat dissipation. So this is such a small package. And you can see here the mini evaluation module. This is a thermal imaging we have done again on the mini evaluation module at full typical load and room temperature. And you can see the board temperature and the IC temperature are at a very reasonable level. And you can see on the right measurement of the die temperature for a different condition at room temperature and 55 degrees C. And you can see again that the die temperature is at acceptable levels. So this is the heat dissipation is very much controlled for this solution. And this concludes my presentation for this LM10692. And for more information, I encourage you to go to the Texas Instrument website, ti.com/LM10692, where you can find more information on this device. You can download the data sheet, and you can also order evaluation module. Thank you for watching.